What up, guys? What up? What up? Again, I am Lou, and today, guys, I'm making a video related to databasing. In this case, we're going to be talking about some of the slight differences between Microsoft SQL Server and Postgres. So, though the reason why I'm focusing on these are the two that I actually use a lot. I use very often. I have a few years experience working with both databases, so I kind of became very familiar, right, with in and outs of a lot of these two databases. And because of that, I want to kind of share some of the differences so you're aware of it if you're ever switching from one to another. But before we get started, guys, hit that like button, give me a follow like always. Appreciate all the support, and let's get started. So pretty much what I did, I put together here, as we'll see, on the left side, this is SQL statements for Microsoft SQL Server, and on the right side is for Postgres. You can tell up here in the top right, Postgres SQL Server. And the main reason, my main purpose behind this is, I know when I first started learning databasing, I started with SQL Server. When I made the change and I moved from SQL Server to, I think it was Oracle maybe, dude, there was things that I just was not aware of. Now I was aware of to some degree, because when I end up getting another job somewhere, they use Oracle. So I was like, all right, let me kind of review Oracle a little bit, see what's, if there's some nuances, because I knew there were some changes, just wasn't exactly sure what. But man, there's things that, again, when I started, trying to write some statements that were just, I was getting errors. I was like, dude, how do you do this? Like, how do you do that, right? As you start writing it, how do I convert this? How do I, whatever? And, it just kind of became a learning curve, right? I just wish I was a little bit more better prepared, I guess. So what I'm trying to do here is, give you awareness. If all you have used is one database only, and you're switching to, let's say all you have used is SQL Server, Microsoft SQL Server database, and then now you're switching to Postgres or Oracle, for example, I want to make sure that you're aware of that there's going to be things that are going to be different, things that maybe you already know how to do very well in SQL Server that are not going to be done the same way at all in Postgres or in Oracle. They're just not, man. They're like going to be completely different. So you're going to have to do research. You're going to have to be aware of it and get familiar with it. And just, that's my main purpose with this video. So one thing I want to kind of just make you aware of, in SQL Server, whenever you create a new instance, a new database, for example, there's a default schema. There's other schemas, but there's one default schema, which is DBO. So this is the default schema, which means if you create any tables, views without specifying a schema, they all go to the DBO schema by default, because that's the default schema. So that's something to keep in mind. Now for Postgres, it is public. Same thing, right? If you create any tables, views, procedures, whatever it is, but you don't specify a schema, it will go automatically to the public schema. Now again, there's other schemas on both as well that are used for like system purposes, but these are the two default schemas, so just keep that in mind. Most of the time, it may be fine to create your tables and views in the schemas. A lot of the time, you want to separate it. You want to create specific schemas for the purpose of staging. Maybe you want a staging schema. Maybe you want a reporting schema. You want an accounting schema, right? There are purposes to have different schemas. So if we look down here, this is one example of running a select statement in each database. In this case, you will specify DBO, which is the schema.table. Public, again, the schema.customer. Oh, my bad. Yeah, the table, which is customer. Or you could run it this way. Do not even specify the schema. Because it's coming from the public schema, the default schema, better yet, you don't even need to specify it. This sounds fine. Like, oh, that's easy. I don't even have to specify it. I personally don't recommend doing that. I recommend to always specify your schema. And the reason why, if you do it in advance, and let's say in the future, y'all decide as a company, organization, etc., or whatever project you're working on, hey, we're gonna create this new schema for X, Y, and Z. And let's say you create this new reporting schema that you're going to be using for reporting, because now you want to separate the operational transactions from reporting, and then you happen to give it a same name of what you have in your other table called customer. Well, you're going to have issues every time you type it. It's going to be pointing to the public schema if you don't specify in the schema, or you're going to have issues where visually it may be confusing, like you have this customer table in the public schema, and then for the reporting one you have to specify reporting.customer, and then if you start giving alias names, then that's where it becomes hard. Well, which one is coming from which, and so on. So again, just to minimize all of that kind of stuff, I would just recommend, dude, from a best practice, specify your schemas, man. It'll help down in the long term as well, and keep things more readable. So now let's look at creating tables. So if we look at the SQL Server, how we create tables, the first statement, the first line is pretty much the same as Postgres. The only difference, again, is the schema. Schema is different, but if you don't specify the schema, it'll still create it, right? Just FYI, it will just create it to the default schema. But they're pretty similar, the way that operates. And then we're going to look at first column. In this case, we call it ID. So I call it ID because it's going to be a system generated identifier. So in order to do that in SQL Server, I did call this an integer data type because it's, you know, numeric. It could be big int or integer. Integer, I mean, it's a 4 bit, you know, data type. But again, for, you know, that's all it is, right? Integers are whole numbers, so that's what I'm using. This is where it becomes different. In order to do it, you have to call this identity. You know, you got to specify the identity, and in this case, it would be 1 1. And the reason why I picked 1 1 is I want to start on number 1 and increment by 1 value. So if you want your records to start at number 1 million, then you will specify 1 million, then you can increment by 1. Or maybe you wanted to start at, you know, I don't know, 900, whatever it is, right? Or maybe you want to increment by 5. So let's see, oh, okay, I want to start at 1, but increment by 5. So your records in your database would be 1, 6, I guess, or whatever, right? We'll just increment by 5. So that's kind of what this does here. If we look at SQL Server, not my bad, Postgres, we have this data type called serial. So what this does, just so you're aware of, it's not a true data type, but what it is, think of it as more of a method in Postgres, where when you specify this as a data type, what it actually does is it does set this column as an integer, but it also generates, it does two, it's a 2-for-1, think of it that way. It does set your column as an integer, but it also generates a sequence for this column, and the sequence being where as you add new records, there's this sequence function, I guess you want to call it, and that would increment up that new records that are being added. So again, these two, they give you the same results. When you create new records here, it will increment by 1. When you create records here, it will increment by 1. But the way you do it is different. You could tell this will be serial. That will do both. Will generate a column and label. It will be integer data type. But it also generates a sequence function that will increment your record count, right? Your ID. And this one does the same thing, but you do got to specify the integer data type, and then of course your identity as 1 1. So kind of be able to when you want to start and so on. Now these other 3 columns, they're pretty much identical. Varchar 50, not known. So the reason why we put not known means there has to be a value in here. If you're okay with there being a no value, maybe for age, you're like, well, I don't need age, it's optional, then remove it. So you have to do remove it. If you remove it, then it becomes optional. But if you specify not known, there has to be a value. That simple, it has to be a value, right? So just kind of keep, you know, be aware of that. So now we're going to look at is active. This is different as well from Postgres SQL Server. And SQL Server, there is no Boolean data type. right? So in order to the data type that we would normally use to kind of represent the same thing would be a bit. So in this case, a bit is you have two values. It could be a 1 or 0. That's it. There is no other options. Just 1 or 0, and 1 being true, 0 being false. At least that's how I would represent it, anyways. If I wanted this to be like a Boolean type indicator. And of course, in Postgres, you have a Boolean data type, and in this case, it's true or false. So this one, I think, a little bit more clearer for sure, because if you have a column called is active, it will say true, it is active, or false is, it's not active. Also, if you look here, we have this default. So this is kind of the same on both, but this is ultimately if you want to default a value to it. And of course, default means you don't have to specify this when you create a new record. So if I were to create a new record and all I provide is these 3 values, I don't need to provide this value because it's going to default to 1. Now I can provide a value. Let's say I could provide a value of 0, and it will set it to 0. But if I don't provide a value, I'm going to default to 1. That's ultimately what that means. And then we get to our last column, created data type, date time. My bad. Created date time. So this is a date time value, right? Date and time. In order to do that in SQL Server, it's called date time is our data type. Where in Postgres is timestamp, right? So they're different data types. These are not even the same data type, completely different. Now, and then you have a default, same thing. We don't want to provide this value. We want to default it based on the database time configuration. In order to do that, there's a function called getDate in SQL Server. By calling this function, it's going to default it to the current date and current time, right? So just kind of keep that in mind. In Postgres, it's called now. I like now better than getDate. I mean, for me, that's more clear, straightforward. But either way, I mean, just at least you're aware of, right? The way they give you the same results, but they're different. One is called getDate, the other one called now, right? That's ultimately the difference. So as you could tell, there are some differences here when it comes to creating tables. If you're used to doing it in SQL Server and you're used to doing this, now when you're doing Postgres, it's not exactly the same. Now there are a lot of similarities, you could tell, but it's not identical either, man. Like this is different. The Boolean will be different. Now there is bit in Postgres, but I would recommend to use Boolean instead of bit in Postgres. That's my opinion anyways. And then ultimately you have, again, timestamp for instead of date time. And then the function of now would be instead of getDate, right? So those are some of the differences. So the next thing that we're going to look at is going to be, let's say we're trying to get top 10 records. So in SQL Server, it literally will be select top 10 star for all the columns, then the table name and the schema. Well, in Postgres, you don't do that. What you do would be select star from, then it's limit 10, right? So this is the difference. This is top 10. This is limit 10. So again, same results. You get the same results back, but the way you get them back is different. So that's kind of one thing I'm just trying to emphasize to make sure everybody's aware of. One thing too that I don't know if you have noticed is assuming that if I really wanted to run this whole file here that I have, see how I have these semicolons at the end to separate each statement? In SQL Server, you don't have to do that, but in Postgres, you actually have to do that. It will cause issues if you don't do it. So just FYI, like you have a procedure that has many steps where you're querying, then you're updating, then you're loading or doing whatever different things in that procedure. You do have to specify every transaction that you do. Once you're done, be semicolon, then you go to the next, section. Postgres, you don't have SQL Server. You don't have to do it. Now, one of the things you most likely could do in SQL Server is more doing the go statement. You don't have to, but what this does is when you put go in between, it executes this statement, then it goes on to the next statement. If I remove the go statement, what it does, it actually executes both of these. And if there's any conflict, it, ultimately could cause issues. But if not, then it should be fine. Yeah, just, again, same thing, little nuances, be aware of. But Just kind of be mindful of. So the next thing we want to look at is, well, what if we want to convert a date time column to date? Well, again, in SQL Server, there's a convert function that we use. You specify it to, this is what, what do you want to convert it to? So in our case, we want to convert it to a date. So this is the data type, right? We want to convert it to a date. And then you got to specify the actual column. In our case, it's this column here, right? Created date time, which is the date time column. And then as, if you're not familiar with as is just saying, I'm giving this a new name. This is my column, but as you could tell, because I'm using the convert function, it really doesn't have a name anymore. So I want to give it a name, and that's where as comes in. I call it created date. That's the new name that I give it. Where again, if we look at Postgres, in order to do the exact same thing, and I think for me this is way more easier. I like this approach way better. You do the did I call this semicolon? Damn, okay. I need to understand my special characters. But over here, your semicolon would be date. And then of course, same thing as created date. So way more easier to convert from a date time to a date format. So, but again, these are things where if you're switching databases, if you're not familiar, you're going to be stuck if you're trying to figure out, damn, how do I do that? There are some ways, what I want to call standard ways that you can do cast, and cast actually works for both SQL Server and Postgres. But again, keep in mind, every system, every database has their own ways of doing certain things as well, and this is the way you do it in Postgres and SQL Server. So now let's look at views, right? So we're going to take a look at views here. If we compare the views, in order to create a view in Microsoft SQL Server, literally is called view, create view, and then schema, the name of the view. So in this case, I call it VW for view underscore customer. That's the name. Then it will be as. Then of course you specify the statement, right? Whatever statement it is. So in this case, we specified select the columns, like I'm converting this to create a date, and that's it. We're done. This will create a view. Now, if we look at the Postgres version, it's pretty much almost identical, right? Like you have your as, select your statement, that's all the same. The difference is you could specify, you could do it this way in Postgres, but you could also do it this way by adding the or replace. I always recommend use create or replace, because let's say if you're working on it, you create it, and you're like, oh man, I forgot to add a column. You could go ahead and add your column, then run the same statement again. And what's going to happen is that's going to update it. If you do that over here with SQL Server, that's not going to work, because this only creates. Once you create it, you can't update it no more. In order to update it, which is the next piece, you got to use the alter statement. Again, you got to use a different statement in order to update it. Where with Postgres, that's not the case. You could have both, ultimately representing both actions in one statement. So if you do have to update, you just rerun it and it will update. You don't have to change a statement from create to alter in order to update it. So again, we look at the update view for Postgres. You will see this is identical to the way it is to create. Identical, man, has not changed. Now you will see it here in my update statement. I added some a full name, right? So I created this column called full name, and I'm concatenating first and last name. But I want you to see how it's different from SQL Server to Postgres. In SQL Server, you could do plus whatever text value you want, which in this case is just a space to separate the name, and then I'm of course plus to concatenate the last name. For Postgres, that's not the case, using the pipe characters. So first name, pipe, again, same thing, space, character, and then pipe to concatenate, and then of course last name. These are some of those little nuances, right, that I mentioned to you that it is going to be different. So, and I'm just showing you examples of SQL Server with Postgres. Well, these nuances go beyond these two languages, right? if you're going from Postgres to Oracle, there'll be some other nuances. If you're going from MySQL to Oracle or Post, whatever, right? You're gonna always find the little nuances. So just again, still recommend learn SQL, like the core SQL language, because all of the databases use that in one way or another. Like the majority of it, it's SQL, the default language, but they all have their little special nuances on how they do certain things, right? They have their own custom functions that they have created. The procedures are slightly different. You know, they have their own procedure languages. Again, there's a lot of little things that do vary that are slightly different. But again, the main purpose was here to kind of share with you that there are these changes, man. There are these nuances, and just be aware of it, kind of understand it. So if you are switching roles and you have always been working with one database only, before you go to that new role and working on a new database, do some research, understand that certain things will be different. And of course, as you go, right, as you start building new procedures or views or whatever your new role, you just do some research, kind of figure out, well, how do I know how to do it this way in this other database. How do I do the exact same thing but in this other database, right? Because it is going to be slightly different. Again, guys, hopefully this helps out. I am going to be doing more database content, so if there is anything specific you want me to make, shoot me an email, let me know, or send a comment. I'd be more than happy to go over, you know, make a video over something more specific if you have anything. But again, I do think database is good to know, have under your belt, and be decent at the minimum, right? So hopefully this helps out. Again, guys, appreciate it. You know, thanks for all the support. Hit that like, hit that follow, and talk to y'all later. Peace.